Welcome. This video explores the fascinating world of emerging database technologies. We'll delve into next-generation database innovations and discover how they're shaping the future of data management. Get ready to explore the cutting edge of database technology. Let's take a quick look at the database evolution timeline. From the 1960s to 1970s, the era of hierarchical databases was popular, using technologies like information management system and adaptable database system. The 1980s to 2000s marked the relational era, with structured query language and relational database management systems dominating. The 2000s to 2010s saw the rise of NoSQL databases like MongoDB and Cassandra. Now, in the 2020s and beyond, we're entering the next generation of databases, including artificial intelligence native and quantum databases. Now let's explore graph databases. These databases focus on relationships between data points. As you can see in the visual, users' products and orders are connected, showing how a user viewed a product, placed an order, and what the order contains. Some key features include relationship-focused storage, complex query traversals, real-time recommendations, and social network analysis. Graph databases excel at managing and querying interconnected data. Next, let's discuss vector databases. These are designed to handle embeddings from machine learning models. As the visual shows, images, texts, audio, and video can all be represented as vectors, and the database helps find similarities between them. They are highly used in artificial intelligence-powered search, where the semantic similarity is the goal. Here is an example of similarity search using code. You can see how a query vector is used to search the database for the top 10 most similar vectors. Now let's explore time series databases. These databases are optimized for handling timestamp data. The chart visual represents Internet of Things sensor data flow. On the x-axis, the timeline is shown from 0 hours to 18 hours, and on the y-axis, temperature is plotted. Some optimizations that make time series databases efficient are time-based indexing, data compression, window functions, and real-time analytics. They are ideal for applications involving monitoring and analysis of data over time. Now let's move on to NewSQL Databases, which provide the best of both worlds, combining structured query language compatibility with horizontal scalability. They support atomicity, consistency, isolation, durability transactions, and are designed for cloud-native environments. Here's an example of distributed structured query language code. You can see how to select the customer ID, the sum of order amount as total from distributed orders, where order date is greater than or equal to the 1st of January 2024. It will group by customer ID and order by total in descending order. Let's discuss multi-model databases. These databases can handle different data models in a single platform. They support document, graph, key value, and relational models. All of these models are available in one database. This approach simplifies development and deployment, offering greater flexibility. Now let's talk about serverless databases. These databases provide instant provisioning, automatic scaling, cost optimization, and eliminate the need for infrastructure management. As illustrated, they offer auto-scaling, pay-per-use, and zero administration. These databases are ideal for applications with variable workloads and reduce operational overhead. Let's peek into the future with quantum and artificial intelligence native databases. Quantum databases leverage quantum supremacy and exponential speedup for complex optimization tasks. On the other hand, artificial intelligence native databases feature self-optimizing queries, predictive scaling, and intelligent indexing. These technologies promise to revolutionize data management in the years to come. In conclusion, the database revolution is here. We're seeing a shift towards specialized, intelligent, and seamless data management. Technologies like graph, vector, time series, new structured query language, multi-model, serverless, Quantum and artificial intelligence native databases are paving the way for a more efficient and powerful future in data. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.